Hey everyone, in this video we're going to be talking about something I find very interesting. Um, this concept was new to me prior to uh, this lesson, and it has me wanting to invest money. Um, just you'll see why. Trust me. Okay. So what it is called it's an annuity, and plural annuities. So we have been talking about previously on Mr. Beal's class. We have been looking at making single lump sum deposits. Okay? Making one deposit and just letting it be. And what an annuity is you are making a sequence of equal periodic payments and gaining interest as you go. So to give you a visual, so let's say so what it means to have equal periodic payments is, say, after 1 month you make a payment. After the second month you make that same payment. And as we go along, we're gaining interest. After the third month, you make the same exact payment. And then you kind of continue this out to just some number, and at that some number, you make that same payment. You're making one payment over and over again at a certain period of time. Okay? So what we're going to be, what an annuity kind of leads us towards, and what's really interesting to talk about, is the money you get from it. So the total value of the investment. I want to say here, this total amount, it includes all of the periodic payments with all the interest that we accrued. Okay? So this total amount is known as the future value of the annuity. Okay? So in this video, we're focusing just on that, determining the future value. So we'll say we're making equal payments of $80 every month at this interest rate. How much money will we have in 50 years? That sort of idea. So the formula to determine this for the future value of an annuity is above. And we see that it is R okay. And we see the I in here and N. So where I is simply the rate divided by the compounding period, and N is the product of the compounding period and the time. Okay? Let's go ahead and look at, I should say R. R is the payment that you're making. That's, yeah. So let's look at this situation. Okay. So we see here in this example, Emil is going to be making, I think it's pronounced Emily actually. It's a unique name. Emily makes a payment of $500 into a mutual fund. So a mutual fund is a type of annuity. If her investment earns 7.88% compounded quarterly, what will the value of her annuity be in 20 years? So again, writing our formula down, always wanting to do that. Okay, we have the amount that we're paying. We have the information needed to find I, so that's R divided by K, so that would be 0.0788 divided by quarterly, so 4. And then we have everything needed to find N, so that would be K times T, or just 4 times 20 years, so 20. So let's see, when we divide 0.078 0.0197, and this is going to be, I think, 80. So let's place everything in. So you have 500. I just want to say this payment number is not with the numerator of the fraction. I made that mistake once. This payment amount is being multiplied by this huge chunk, okay? So I'm just going to help me here by putting a large parenthesis signifying that they're separate. This gets raised to 80. You divide by 0.0197. Okay. So in doing this, let's see what we get. So 500 multiplied by, let's use our little fraction bar, 1.1 plus 0.0197 raised to the power of 80 minus 1 divided by 0.0197. Okay, just checking everything over. Everything looks good. Whew. Do you understand what we're seeing? Give you a moment to think about this. So, she is depositing $500 every, 4 times a year. 4 times a year she's depositing $500. After 20 years, she has $95,000 in this annuity. Can you see now why I'm interested in this? I've actually talked to people about, how can this be done? How can we do this? I know people who have their whole house paid off, have all their cars paid off because they've invested money this way. Their kids went to college paid for because they invested money this way. It's very interesting to me. I'm sure dealing with money, it probably interests you as well. So she, this is the value of her annuity after 20 years, starting with just $500 payments. So let's look at one more example. So let's say we have, let's see, Amy. Okay, so this is something maybe a little more possible for you. Amy contributes $50 per month into the Lincoln National Bond Fund. So I'm sure we could find some sort of mutual fund or annuity in this area. But let's say she deposits $50 every month, and she earns 7.26% annual interest compounded monthly. What's going to be the value of her investment after 25 years? So let's write our formula. Okay, so we have our monthly deposit of $50. We have the information needed for I. Monthly, so that would be 12. And then 12 times 25. All right. So doing this, we get 0.076 divided by 12. That does not seem right. 0.0726. Easy fix. 0.0726. There we go. Okay. And then 12 times 25 is 300. So placing everything in, okay. If you did not want to do this every time, if you'd rather just use the capability of the calculator, this is what it would look like. So we have 50. So we want fraction bar. 1 plus. I'm going to use another fraction bar. 0.0726 divided by 12. Close the parenthesis, raise it to the power of 300. We subtract 1. And the bottom is going to be another fraction bar. 0.0726. Okay. And we get $42,211.46. Depositing $50 every month. After 25 years with this interest rate, you would have $42,000 in your account. So noticing that's not 90-some thousand, just because of the difference in payment each month that you're making. That's still a considerable amount that you're only depositing $50 every month. Out of curiosity, before I give you one more problem to do, if I'm putting in $50 every month, so $50 every month, so in a year, that's $600. Over 25 years. So Amy has put in $15,000. That's what she's placed into it. And with interest, that has gone up to $42,000. It's again just interesting to see. Now, to close off this lesson, it's a rather short lesson. If Amy wishes to earn $100,000 from her bond fund, what should her monthly payments be? So we're going to be using here the same interest rate, and she's again going to be, the interest rate is compounded monthly again, but we do not know what the monthly payment's going to be. So it's a little different. I'm giving you the end result, and I'm asking for what the monthly payment will be. So the solution can be found in the notes attached, but like always, any questions you have, post them in Google Classroom.